Pozdravljeni v avtomobilnosti. Pa smo jo dosegli, 500 namreč. Z novim Renaultem Scenikom sem uspel prevoziti 500 km, preden sem ponovno moral obiskati električno polnilnico. No, če sem čisto iskren, enkrat smo to 500 v avtomobilnosti že dosegli. To je bilo na poti od Bodenskega jezera, ko smo se vozili čez Alpe, no, ampak takrat smo jo dosegli predvsem po sili razmer. Na tisti regionalni cesti je bilo takrat namreč zelo težko najti delujočo električno polnilnico. Zato smo se morali voziti po polžje. Tokrat pa ta številka ni bila dosežena s težavo, ampak pri povsem vsakdanji vožnji. No, da bomo natančni, dosegli smo jo pri mešanem ciklu, tako kot vozimo vse naše testne avtomobile, torej tretjina avtoceste, tretjina regionalke in tretjina mestne vožnje. Vozili smo pri temperaturah med 10 in 15 stopinj Celzija, kar je po mojem mnenju kar dober oziroma tipičen primer neke običajne spomladanske rabe tega avtomobila. Tudi za tiste, na primer dnevne migrante, ki boste s tem avtomobilom več vozili po avtocesti, imam dober podatek. Sam sem se namreč tekom testa odpravil tudi do Dunaja, takrat sem v avto naložil celo 5 oseb z vso pripadajočo prtljago, no in tudi z te poti lahko poročam o ugodni porabi energije. Ta je takrat znašala le nekaj nad 20 kWh na 100 prevoženih kilometrov. Kljub temu, da imajo nekateri električni avtomobili še celo večjo baterijo, kot jo ima Scenic, pa 500 ne dosežejo ravno pogosto. In v čem je nauk te zgodbe? Skrivnost tiči predvsem v učinkovitosti električnega avtomobila. Zato se ob nakupu električnega avtomobila ne ozirajte samo na to, kako veliko baterijo bo imel oziroma kako velik je skupni električni doseg. Predvsem pozorno preverite teste, kako malo energije bo porabil za 100 km vožnje. Zakaj bi na primer v hribe nosili težak nahrbtnik z robo za en teden, če pa vemo, da bomo tam preživeli le en dan? Renault je torej s Scenicovo baterijo več kot očitno zadev tisti sweet spot, kot mu radi rečemo. Torej, velikost Scenicove baterije je zelo pametno odmerjena. Predvsej pameten pa je ta avto tudi na področju asistenčnih sistemov. V pomoč sta mi bila najbolj, na primer, sistem za ohranjanje sredine voznega pasu in pa pametni prilagodljivi tempomat. Predvsem zato, ker ne delujeta zelo invazivno, ampak na naše voznikove reakcije odreagirata zelo zmerno. No, ampak seveda, ko vozimo s Scenica, morajo biti naše roke še vedno čvrsto na volanu, naša čutila pa še vedno povsem pri stvari. No, ampak zdaj pa bomo presedli v avto, kjer to ni več nujno. Nissan nas je namreč povabil v Leafa, ki nam pravi, danes pa peljem jaz.
Če boste slučajno med vožnjo po Veliki Britaniji na cesti srečali takšnega Nissana Leafa, mu nikar ne poblendajte. Tudi če mu boste želeli odstopiti prednost takole z roko, vas ne bo razumel, zato ker gre za avtonomni avtomobil. Ta avtomobil se je že dokazal, da zna voziti po avtocesti. Vozil je naprimer tukaj od Kremfielda do Sunderlanda, kjer je Nissanova tovarna, pa avtomobil se je tudi že dokazal v mestnem okolju. No, zdaj pa je zaključen projekt, v katerem so s tem avtomobilom vozili po podeželskih cestah. In seveda, prav ta vožnja po lokalnih cestah je zares fascinantna, zato ker v teh situacijah se mora ta tehnologija odzivati, kot bi se odzival kompetenten voznik. In ja, prav posnemanje človeškega vedenja je dejansko tisto, kar najbolj fascinira pri tem avtomobilu. Ampak zdaj je čas, da se gremo peljati.
Did you experience during the drives some of the angry drivers behind you?
Not in this vehicle. We are rarely the slow vehicle. So, as you will see today, we are driving when safe to do so at the highest speed it can manage.
What I've taught my Japanese colleagues is the expression "go-reen," and I made them say it back to me, "go-reen," and then I said, "Now make it go on the "g" of go-reen." And so when you now see the vehicle, so before it would go green, and then maybe one second later the car would go. Now it goes straight away.
Wow, that is fast.
You have mentioned humanizing technology.
Yes.
Technology and humans, that is something that cannot go together.
So what we're trying to do is develop a car that mimics a competent human or an advanced human driver.
So a car that thinks like a human.
A car that thinks like a competent human. Okay? And what I mean by a competent human is somebody, especially in the rural aspect, who's always glancing to their left and glancing to their right. Actually, an autonomous vehicle is looking to its left, looking to its right, looking forward and looking rearward, all at the same time. It will be safer.
Why is rural driving so advanced? If you compare it to the highway and the urban.
So the road surface is not very good. The lane markings are not very good. But also the speeds of both vehicles is quite high. You have, say, around 200 kilometers net in both directions. This means decision-making of vehicles and their speed needs to be made incredibly quickly. So many of the systems on this vehicle have to be run at a much higher rate.
That also means a lot more computing power.
Similar, but just reallocated. For city, we have to look at the pedestrians. We have to manage all of the vehicles around us to maintain their position. For here, we focus on very few vehicles, but making decisions very quickly.
Give me a figure, how quickly?
The normal calculation is about 10 hertz, there's a constant cycle for the city. That is maintaining where all the objects hit. For here, at the fastest, you have like 30 hertz. So 30 times a second, this calculation needs to be run.
It's true.
A competent driver can also be angry driver, scared driver.
Yes, and this is where we come to inclusivity, what we're trying to do. And you are right. Key message, first of all, is we are not trying to take the fun out of driving. What we're trying to do is take the boredom out or the anxiety or the stress out. When people go down onto motorways, down the slip road, there are people who, I call it slip road phobia. They start giving way when they should be picking up speed. When they get on the motorway, the cars around are going high speed. People get stressed, don't like this. And then you go into the city centres. Too much signage. Which lane should I be in? What's over there? Who's that? What were they doing? And then, of course, rural roads. You know, some people don't know this area. You've been diverted late at night off the motorway or something like that. That happens a lot in the UK. And you're diverted off and you get stressed. You press the AD button. It gets you through that bit. And then when you get the other side and say, I know this bit of the road, I'll take over. This is fun. So that's what we're trying to do. And that's what we're trying to achieve.
That's kind of future I want.
Did we go very close to the curb?
Yes, we moved close to the curb, but the vehicle knows how wide it is, so that's why we can get within a centimetre.
Yeah, that was really less than 10 centimetres.
Yes,
I would say.
yes. It will always try to stay in the centre of the lane, but it's adaptable. So if we detect a large oncoming vehicle, a bus, a lorry, we will reduce our speed, give ourselves more thinking time, more processing time, and the vehicle also may move to the left slightly to give more room.
We were doing testing in the winter, and the grass in the verge on the left-hand side was way back. So as we came to summer and these sorts of times, then we discovered the vehicle was moving slightly further to the left, because as we'd understood that the lane boundary was closer to it than it was originally. So we now do a scan using the LiDAR to detect both the location, but also have an estimation of its density. So if it is grass, we can put a wheel on it if we have to, but we would prefer to remain on the road surface.
Okay. What about the leaves on the trees during the winter and summer?
This creates blind spots. On these country roads, there are always blind spots.
Yeah.
But you are correct. In the summer months, or the spring, I should say, it blooms and you get more trees. And in those occasions, then we were able to detect more blind spots in lots of corners that we did not see before.
What we have to do in Europe, compared with Japan, the car has to be more assertive, okay? Not aggressive, assertive, okay? And what I mean by that is when you've got two lanes, but there's parked cars either side, there's cars coming the other way, and then there's a gap. The car needs to say to itself, that gap's sufficient for me, I can go up there and do that. If it's not assertive enough, there'll be a human-driven car behind getting very annoyed, tooting the horn and saying, come on, get on with it. If you can do that in London, you can do that in the majority of UK cities. And there is no reason as well why it can't be done in any European city as well.
Also in Italy.
Right. There is. Just coming. There is a level of assertiveness. Then Let's say it's not aggressive, but maybe it's high level of assertiveness. Okay, on that side. So yes.
We saw a parked car here on the left side. As a competent driver, I would slow down a little bit and then maybe go a little bit further to the right.
Yes.
Just to be sure that the driver won't open the doors.
Yes.
Is this something that you can predict or no?
So we did reduce our speed slightly. The only thing here is that part of our safety case is the vehicle did move within the lane to the right, but we didn't move into the adjacent lane due to our safety case of having to move into an oncoming vehicle potentially.
So you cannot cross
Move
the lane?
yes.
Okay, why not?
Due to the safety and our risk assessment, we're put...
Of course, but you have a long-range LiDAR in the front, so you know that there's no one.
So currently in this project, we haven't developed that function.
So next project.
Yeah.
We want a society eventually that they'll go, that's an autonomous vehicle. That doesn't understand a flashing of lights or bribbing a horn. I will just go on my way.
So that is something that happened.
Yes. We've had a situation down in London where somebody flashed their lights to let the car go, and then the car didn't go. So they flashed twice, they flashed 3 times, and then they got really annoyed and accelerated off. We have this, in the UK, we have this company called Starship, autonomous pods going along the pavement. And I live in the town where it was deployed 7 years ago. And 7 years ago, people used to try and ride them, pick them up, have their pictures taken with them. 7 years on, everybody just ignores them, and they just go about their business. And that's what we're looking for an autonomous vehicle.
What about cyclists?
We tend to be quite patient. We stay behind.
We have a few animals. We've had deer, fox, and we've had a squirrel.
We will see as we come into NCCE. You will maybe see with the goose. There's a very naughty goose up here.
It keeps walking in front of us.
And because the car is very patient, it's in the water today. He's behaving himself. Good man.
What about drunk driving or using autonomous car after drinking in a pub?
That would have to be a level 5. Following the rules of the road, you can't drink and drive. So, of course. So if somebody was to get in the car straight away and just press the button and say, take me home, and then there was no hands on the wheel, feet of the AD car would do that kind of thing. But if that person said, I can drive this a little bit, that's a different technology we would have to look at. That's outside of the autonomous vehicle sphere. You'd have to make sure that the person wouldn't take over the wheel at any time. There are ways, the car gives you a breathalyzer test and says, no, you're not able to drive, I'll drive you home. The law could be, you can do it, but you've got to be sat in the back seat.
So another project.
Another project, yeah.
Po oglasnem premoru se posvetimo senzorjem za avtonomno vožnjo, natančneje, ali so kamere res dovolj, pa tudi, ali bomo res dopustili, da bodo Toyote driftale namesto nas.
What are the possibilities that we will get these cars as soon as possible on the roads?
Our aim is to launch this technology first as a service. So it is not to sell to the individual customers yet. If we start the service, people will start to use it. People will see a new business chance. And that's how we want to bring our partners to actually develop more technology.
But first you need to convince the authorities.
In the UK and also in the EU, recently there were 2 directives that came out that allowed us to actually test this car on the public road. So this is a very good sign that we can actually start really thinking about launching the service in the UK and the EU. Now we have to talk with the authorities more, making sure that this car, self-driving, will harmonize with the existing traffic.
So we have 4 long-range LiDARs. These are doing the longer detection. Then we have 2 wide-angle. So this is doing a broader down the left and right-hand side, specifically very useful in our city case, where you have all these objects moving very quickly nearby.
Yeah.
Then we have 15 cameras on this vehicle. But also then the final sensor is the radar, which is used as a backup for use of our ACC, so to figure out what speed the vehicle in front is going at.
Tesla says that we can do autonomous drive only with cameras.
We have a LiDAR, we have a camera, we have radars. What the others do is based on their policy. And this is the point that we are discussing with the authorities as well, because we do not have a clear set of standards or rules, but to make it a level playing field and also to ensure the general safety of the public, the standards and rules need to be set.
How we should set the standards?
The standards should be set based on the driving scenes, what it should detect and how it should react, not the exact sensors that are necessary or what kind of a computer that is necessary. That is just a tool.
But here we have a question of redundancy. How can we get redundancy with only one technology? When one technology is limited, for example, by visibility. So if you have only a camera, you cannot see something that only LiDAR could see.
That's a very good point. And that was exactly why we have so many sensors today on our car in our research phase. Now, when we try to mass produce, we want to make sure the redundancy remains, but also to study how can we actually slim down our set of sensors so that in the future we can make this technology available to everyone.
So how far are we?
10 years down the road.
At least, yeah. Okay, but
I will be still working.
Okay,
I'll try to push.
Vodja razvoja Nissanove tehnologije avtonomne vožnje, gospod Shunsuke Shigemoto, torej zagovarja, da je poti za dosego avtonomne vožnje glede na izbrano tehnologijo lahko več. No, vsekakor pa dodaja, da bi morala pravila narekovati, da moramo za dosego popolne varnosti vedno izbrati kombinacijo večjih tehnologij. Pri Tesli so do avtonomne vožnje obrali nekoliko drugačno pot. Opustili so lidar in radar ter se osredotočili na sistem vision only. Torej to pomeni, da avto vso svojo okolico zaznava le s temi številnimi kamerami visoke ločljivosti. No, ampak v resnici je bila tudi to domislica Elona Muska. Inženirji Tesle pa se s tem niso v popolnosti strinjali. Muskov argument je ta, da ljudje vozimo samo s pomočjo vida. Zato mora biti to dovolj tudi za umetno inteligenco. No, ampak vprašajmo se, ali je to prava pot? Poglejmo en rezultat, do katerega je prišel nekdanji NASIN inženir Mark Rober. Rober je torej v stilu cestnega dirkača vkanil Teslo, ki je v stilu Toyota nasedla na trik, ko je na zid naslikal nadaljevanje ceste. Seveda je takšen scenarij precej bolj verjeten v risanki, kot pa v realnem prometu. No, ampak Rober je s svojim eksperimentom dokazal, da ima lidar pred kamero verjetno neulovljivo prednost. Tako kot lahko v zahtevnih pogojih hitro zatajijo naše oči, lahko zataji tudi vid kamere. No in ravno zato je dobro imeti rezervo. In ravno kombinacijo tehnologij zagovarjajo skoraj vse avtomobilske znamke. Za pregled nad omejitvami posameznih tehnologij vam res toplo priporočam, da si tudi sami ogledate Roberjev test. No, kako se je na našem testu odrezal novi Teslin model Y s kodnim imenom Juniper, pa lahko že preberate na portalu mmc.rtv.slo.si. Seveda smo temeljito preizkusili tudi Teslinega avtopilota in preverili, ali je v naselju še tako trmast kot nekoč. Da jaz, recimo, to je sam naredil.
Kaj sam zapremil?
Ja, pa tu, on se paničar vedno, ko gre avto nasproti, če ni v čisto črti. Pač v bistvu, takoj, ko hočeš nekega skensla, ne? Veš, ti ne moreš čisto način puta mu ne moreš dati. Tako je konc. Zdaj bomo mogli obrniti.
Hoče či sam, da vozi, kaj?
Ja. Prevzemanje in vračanje novinarskih avtomobilov nam skoraj vsakodnevno resnično vzame ogromno časa. Sploh če moramo, na primer, ven iz Ljubljane, dokoder ne vozi mestni avtobus in tako potrebujemo še dodatno logistično pomoč drugega sodelavca. In seveda nam je kar hitro padlo na pamet, kaj pa če bi se avto kar sam pripeljal do nas. Nissan je tega vsekakor sposoben, s 4. nivojem avtonomije je pripravljen, da bi ga morda lahko pa kar samega poslali po opravkih. Tako bi nam lahko avtonomna vožnja, proti kateri očitno nezadržno korakamo, močno olajšala delo. No, ampak tako Toyotini kot tudi Nissanovi inženirji so nam dejali, da nas nikakor ne podijo izza volana. Tudi v prihodnosti bomo lahko uživali v vožnji. Zato Toyotin primer avtonomnega driftanja vzemite zgolj kot izvrstno demonstracijo sposobnosti tehnologije. Ker driftanja in ostalih dirkaških užitkov tega pa res ne damo.
My name is Avinash Balachandran. I'm the Vice President of Human Interactive Driving at the Toyota Research Institute.
You have mentioned the word d.o.o, right?
d.o.o, yes.
What is this?
d.o.o is the idea of human-centered automation. So if you look at the actual Japanese characters, it's a combination of the character for automation and the character of a human. And the idea of d.o.o is having technology amplify people. To help you kind of go beyond your physical and mental limitations.
Go beyond physical limitations.
Yeah.
What does it actually mean?
One of the key tenets of d.o.o is that we're not trying to replace a human. We're not trying to use technology to do what a human does.
In the presentation, you have mentioned the driving limitations. But when I was sitting in the car while driving very fast on this road, I thought of myself, I could also drive so fast as easily.
Okay.
But I would love to have a system that would predict now is the time to turn because of the next corner.
You know, you can think about using this technology for a few different applications. So one is a safety system. Imagine traction control, but better, right? Helping you in snow. The other one is kind of like you mentioned, using the system to actually teach you to be a better driver. And so that's actually an effort that we have at TRI. We call it driving sensei. So imagine that your car has an AI that's actually teaching you to drive better. So if you're on a racetrack, for example, it's telling you what's coming up. It's helping you get the right line. It's helping you understand the brake points. It's helping you control the car when it's sliding. And so this is actually also something that we're looking at, building out platforms that can do this. And we have some really cool technology and demos that we've actually demonstrated in California, where our office is, where you can get into a car and it can actually teach you how to drift.
Teach me how to drift.
That's right.
Okay, but how can we this racing driving transform into normal driving on the road?
We hope to be able to use this technology to teach you to be more like an expert driver, and that will make you safer on the roads. The second one is to use it in current safety systems. So let's say you're driving and a deer jumps out in front of you on the road. Maybe this technology can actually help change your steering, throttle, and brake. So let's say you make a big steer and you would normally have gone off the lane, off the road, but this car is able to correct it and allow you to slide a little bit around the corner in order to avoid that obstacle and stay on the lane. So that's kind of how we're thinking about doing it.
Okay, but at the moment, this technology is too expensive. You're relying on GPS technology.
Right.
How can we get somehow this technology
so really the big challenge and what humans do really well is able to deal with uncertainty. So GPS is just one example of that, where computers generally need to know much more precisely where they are, what's around them in order to handle them. And so one of the big current research areas that we're looking at is how can we incorporate better uncertainty modeling and handling within the AI. Can the AI, much like a human, see a new situation and be able to learn to that? And one of the really interesting things that's happening in AI right now is a lot of the new techniques that are being used in generative AI. For example, diffusion that you see that powers things like DALL-E or ChatGPT kind of technologies can also be applied here to help us kind of deal more effectively with these uncertain environments. One of the challenges that we have here is, like you said, we require very precise information, for example, of the friction levels on the ground. And if we could through an AI model, actually capture a little bit of that uncertainty so that the car is able to work across a broader range of friction values, then we can actually incorporate that directly into the controller and have it work effectively. So for the video I showed you with the tandem drifting, actually one of the cars using a neural network tire model. So instead of just being physics-based, it's using data and it's able to actually generate kind of a better estimate of how much tire forces it has so that it can better handle that situation.
So AI still needs a lot of sensors to get the data?
Yeah, so I mean, if you think about a human, you know, we have our eyes, we have our ears, we actually get a lot of sensory input through them. And, you know, I think through your eyes or something, it's a very high number of bits per second. I can't remember the exact number. And so, you know, if you want an AI to have, you know, equivalent performance to us, it generally needs, you know, a lot of sensor input as well. Maybe not exactly the same sensors. So maybe there's a different combination that we can use that will make it more effective. So an AI, maybe it's using cameras and GPS, but it doesn't need the GPS to be as accurate, right? If it has a camera, they can balance that off. So I think a different combination of sensors can help make the AI sort of more robust as well.
Is mapping next step in improving the assistance systems in normal cars?
So I think some level of mapping is required, but one of the big things we're trying to do is actually reduce our reliance on these very complicated maps. You know, you and me as a human, we don't actually need maps, right? We can look at a road and decide what to do. So our goal is to try to make the AI as efficient as that. We are trying to actually reduce our reliance on very high definition maps. If we can make the car more robust to dealing with uncertainty, maybe we can use less sort of like high density maps.
Thank you very much.
Yeah, thank you so much. Yeah.
Scenic želi torej z zajetnim električnim dosegom nedvomno igrati vlogo prvega avtomobila pri hiši. Ampak pri tem pa nas seveda zanima, koliko je v njem ostalo še tistega originalnega Scenica, ki je naokoli prevažal toliko družin, tudi v Sloveniji. Danes ima Scenic izključno električni pogon, no pa tudi enoprostorska oblika se je v duhu časa seveda nekoliko preobrazila. Ampak že stari Scenic je bil v notranjosti zelo praktičen. Imel je na primer pomično zadnjo klop, pa 3 ločene sedeže zadaj, ki so omogočali, da se je preprosto namestil tudi kakšen otroški sedež, no lahko pa je imel tudi stekleno streho, skozi katero so otroci na zadnji klopi lahko občudovali krošnje dreves ali pa dežne kapljice. Povem vam, da je veliko te praktičnosti ohranil tudi novi Scenic. Na papirju gre sicer res za SUV-ja, ampak po mojem mnenju gre v tem primeru bolj za mešanico SUV-ja in pa družinskega karavana. Tudi v novem Scenicu se tukaj zadaj, poglejte, brez težav vozijo 3, tudi na dolge poti. Poglejte, koliko prostora imam tukaj zadaj. No, pa tudi stekleno streho imamo, ki je tokrat elektrokromatska in jo lahko po želji zatemnimo s preprostim ukazom Google. Hey Google, close the solar bay.
Okay, darkening the solar bay.
Pravzaprav je notranjost novodobnega Scenica celo bolj prostorna, kot bi to prisodili na prvi pogled, oziroma glede na zunanji videz avtomobila. Poglejte, na primer, tudi prtljažnik je precej prostoren, še vedno je precej velika kocka, tako kot pri originalu. V novem Scenicu torej še naprej ostaja veliko Scenica. Ta avto je kompakten, ampak prostoren, ima veliko baterijo, ampak ni požrešen. No, le na področju voznih lastnosti je velika razlika v primerjavi z originalom. Verjemite, tale se precej bolj prepričljivo vozi v zavojih. Vse ostale ugotovitve z testa pa lahko preverite tudi na našem YouTube kanalu, na katerega se seveda lahko tudi naročite, in pa na portalu mmc.rtv.slo.si, kjer vam razložimo tudi, kako delujejo Scenicovi matrični žarometi, na katerih piše, poglejte, Made in Slovenija. V naslednji avtomobilnosti se vidimo prihodnjo sredo, srečno pa vam ponovno zaželim z napovedjo, kaj boste lahko takrat spremljali. Kateri Toyotin hibrid več prevozi na elektriko, hitreje prevozi ravnino in se bolj močno izstreli iz zavoja? Preverite v prihodnji avtomobilnosti.